Assalamu alaikum. Well, guys, this is a question about a phase difference, concept of phase difference or a path difference. Two identical waves are produced by sources at P and Q. The wave travel along different paths to reach point R as shown in the diagram. That's from May-June 2021, paper 1-1, and this is question number 21. Both waves have a same wavelength, which is 6 centimeter. The waves are in phase at point R. What is the phase difference between the waves as they leaves point P and Q? Now, it's a little tricky in a sense. They have suggested that whatever however they started, right? But when they are reaches at point R, they are in phase. Now, let's imagine this. If the wave P is traveling, let's say traveling, and when it reaches at R, it has a crust. We assume that, okay? Now, another wave is traveling with a different distance. The wave P has to travel a distance of 80 centimeter, and we are assuming that when it reaches at R, it has a crust. Now, this wave Q is traveling over a longer distance than 80 cm, which is 100 cm, like traveling. But when it reaches at R, it's also have a crust. Only in this case, when the crust and crust meet, they must be in phase at point R. Okay. So these two waves are in phase at point R. So it means the source means the starting point P and Q for both the waves. The wave should have a phase difference, some amount of phase difference. Okay. So in that case, let's see P to R, right? It's an 80 centimeter, and when I divided it by 6, I am getting 80 by 6, it's something 13.3333 waves. It means from P to R, the wave P when reaches at R, 13 complete waves have reached, and the 14th wave 0.33 portion, or 33, or like you can say a 0.3 amount of 0.3 is just still left. Okay. Now, Q to R, 100 cm distance has been traveled by a 6 centimeter wave. So 100 divided by 6, I'm getting 16.6666. It means 16 complete waves are there, right? And 0.666 is still remaining. If I take a difference, 16.666 minus 13.333, I'm getting 3.33333. The difference in lambda is approximately 3.33333. It means 3 complete waves are there, right? 3 complete waves are there, but 0.333 amount is a different amount. It's a difference between P and Q. The reason is that path difference must be equal to n times of lambda. If two waves are in phase with each other, they should have a lambda, this factor. And now PD upon lambda, if I should have the value of n equals to an integral multiple 0, 1, 2, 3. But the difference at location P and at location Q between the two waves at 3.333, it means if I just separate 3333, this is the amount of difference between P and Q at their starting point, 0.3 of lambda. Now, a standard formula for finding the PD, path difference out of lambda, is theta upon 360. If I take this 0.333 as a difference between the two waves out of lambda, which is actually in terms of lambda we will calculate. Okay. So lambda will be cancelled out. The theta coming 360 multiplied by 0.33333, I'm getting 120 degree. So the waves must have a phase difference in the beginning of amount 120 degree, so that when they reaches at R, they should have a zero phase difference. This is how we figure it out in a reverse manner. All right, I hope you understand this. Thank you very much.